Right, number 14 then from the 2025 Higher Maths paper 2. Now, I was only going to do one or two of them, just any ones that might seem particularly interesting. And circles, you like circles. Not as much as logs, but circles always make you smile. So I thought, have a try at this one. Well, what does it say? A circle C1 has got this equation. So it's written in that displaced form. And it just says state. Now you've got the formulas at the front, but state means you don't really need to show any working. So state the centre and state the radius. Now I'm actually going to call the centre C1, just for the sake of this. Radius R1. So I know C1 is the name of it, but I'm going to say C1 is the centre. So it just says what is it. So what's the centre? Well, it's whatever's being subtracted. So if that's plus 5, that'll be minus 5. And if that's a minus 6, that'll be plus 6. So negative 5, 6, there's a mark. And that's the square of the radius. So R1 is just going to be the square root of 9, which I'll just go in with as 3. There's 2 marks. Now part B. A second circle, C2. Again, I'm going to call it centre C2. There's its radius C2. It's been expanded out. So the usual square of a bracket, square the first, square the last, in the middle, twice the product. So there's the square of the firsts. Now here's the twice the products. Minus 14x, that's double what would have been there. Plus 6y, so that's double what would have been there. But this last one, this plus 54 is a right jumble, because it's jumbled up from all the bits and pieces that are left over put together. Squaring that, which effectively is squaring the centres and subtracting the 9 produces the 54. Well, you can look up the front, if you like, with your F's and G's, but essentially it's just those have been doubled, so it's just half them and do the same thing. So, what was being subtracted? Half it, 7. Half it, 3. For R2, well, maybe I'll put a little bit of working down, because it was made up of 3 parts. So there was square that, so the square the centres, and then take away the 9 to get this, or square the centres and take away that to get the 9. Well, not the 9, that was that particular one. So it'll be square the centres. 49 and 9, take away that 54. That's 58, 4, square root of 4, 2. R2 is 2. Oops. 4 marks now. Whoops. C. Now the big picture. Circles C1, C2 and C3 are touching, so that's touching internally, that's touching externally. You've got these 2 tangent circle situations. Their centres are collinear, and it says, what's the equation if that's the case? If you draw this circle, so it just touches this one on the outside, on the inside, touches it internally, I should say, and touches that externally, what would be its equation? So that essentially means what's its centre. Again, I'm going to call that C3 and that R3. Well, the radius will be easy to find first of all, because it's all just about distances, playing with distances. You know R1, you know R2, but importantly, since you know the centres, you know the distance C1, C2. So to find this one here, the simplest way, I think, don't know which way you did it, would just be to take the diameter. If I start at this point here and work my way along, what have I got? Well, the whole distance going from there to there would be twice radius 3, the diameter. So what do I do to get from there to there? I'm going to go R1. Then I'm going to go from C1 to C2, because I know that as well. Or rather, I can work it out. But I've gone too far, so I'll go back in R2. That's how I'll work it out. So I've just got to work out this C1, C2. What's the distance between those centres? Well, that's just Pythagoras, C1, C2. How many along, how many down? Pythagoras gets you that. Or you could just look at the numbers. How many along? Negative 5 to 7, that's a 12. 6 to negative 3, that's a 9. Look, 3, 4, 5 triangle. Well, 3 times it, so 15 is the answer for this. But I'll set it out. So it's going to be C2, stop with that. 7 take away the negative 5 squared, which you know is 12. And then negative 3 take away the 6 squared, you know that's a 9. So that's a 12 squared, which is 144. That's a 9 squared, which is 81. So not surprisingly, it comes to 225, which is 15. So the distance between the centres is 15. Now you can work this out. So R1 was 3. 3 to there. Then you went 15, which was a step too far, so you go back 2. So that makes a nice 16. Usually when you get that, when you see that 3, 4, 5 triangles, you know you've probably got it correct, because you'd like to make the question simple in an exam so there's no nasty fractions and decimals and so on, which means the radius is 8. Well, that's part of it. Now I just need to know where that centre is. Well, they're all in a line. You're stepping along a line. You could use the section formula, or you could use that big cumbersome thing that I've never used where they equate line segments and so on, or you could just use vectors. The step, how do you get from C1 to C3? Because you know that already, you've just done it. How do you get from C1 to C3? 12 steps along, 9 steps down. You knew that anyway. So the distance was 15, but the actual displacement going from there to there are those exact same numbers. 12 along, 9 down. So it's from there I'd take 12 steps, sometimes they call that stepping out. You go 12 along and 9 down. So I just need what fraction of the way would I go to get to C3? Well, so now I just need to know this. C1 to C3. That step there. What fraction is that of C1? No, C1 to... what fraction is that of C1 to C2? Well, C1 to C3 is just that radius short, isn't it? So that's 5 steps. You knew that was 15, so it's a third of the way. C1 to C3 is going to be 1/3 of 12 negative 9, so that's 4 steps along, 3 steps down. Now I can put down the answer. So C3 is going to be, so I'm starting at C1, negative 5. Start at negative 5, take 4 steps along. Start at 6 for the y coordinate, take 3 steps down. Which means C3 is going to be negative 1, 3. And that's all you need to put together to get the equation of a circle, which you should sensibly put in this form here. So final part, what's circle 3? I think I'll just write circle 3 because I use C3 for its centre. Circle 3 is going to be x minus the x coordinate squared plus y minus the y coordinate squared equals the radius squared, 64. There we go then.